Okay, so, do you see what's on there? Yeah, you can see what's on there. Problem like this should look familiar. If you've been coming to class, if you've been doing your homework, if you've watched my videos, if you've been doing everything right up to this point, a problem like this should look familiar. Okay? We did problems like this in the middle of chapter 4, where I would say, okay, the sine of some angle is this, and then you had to draw the angle. We said, okay, so where is this angle if the sine value of the angle is negative, but the tangent value is positive? I'm not going to put you guys on the spot, okay? But we had a way of determining where the angle would be based on positive and negative assignments like this. Sine values are negative in quadrants 3 and 4, because that's where the y coordinates are negative on the unit circle. Tangent values are positive in quadrants 1 and 3. So we would know that this angle was down here somewhere, where the sine value would be negative and the tangent value would be positive, and then we would drop a perpendicular, and we'd say, here's our angle theta. And the sine of this angle is the opposite side over the hypotenuse. Is this coming back to you a little bit? Maybe. We use right triangle trig with this. And we say, okay, well this is negative because it's coming down, yada, 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 yada. Okay? I'm not going to go through how we did that back then. I'm going to go through how we can do it now, using an identity. Okay? So here's how we can do that, because they want to know the remaining trigonometric functions. We're missing cosine, cosecant, secant, and cotangent. Okay? Now, there's 4 that we need to figure out. 2 of them are going to be really easy. Right? Cosecant is going to be really easy. Cosecant of theta is the reciprocal of sine. So there's one of the 4 missing identities. Cotangent's going to be really easy, because cotangent is the reciprocal of tangent. So we're going to take this, and we're going to flip it over. Now that one takes a little bit of work, because you'll recall we're not supposed to leave that radical in the denominator. So we end up with 3 radical 3 over 3, and then the 3's cancel. So there's our cotangent value. Now what about cosine? And again, when we were doing this back in chapter 4 or unit 4, we would talk about using the Pythagorean theorem to find this, and then saying the cosine of an angle when we have a right triangle is the adjacent side over the hypotenuse. You can still do that. If that fit for you, if that worked, that's great. But now we have this relationship. And as I said before, there is a connection between sine squared and cosine squared. This relationship will always work for any angle. This will always be true. So if I know the sine of some angle, this no longer is a variable expression. I can solve for cosine of that angle. So here's what I mean. Oh, here we go. I've got this Pythagorean identity. Okay? So understand what we're missing. We're missing the cosine of this angle. I have this Pythagorean identity. Keep in mind, like I said before, this means this, and this means this. And in the problem that we're looking at right now, sine theta has a value of -1/2. So we're going to be doing a lot of substitutions in this unit. Here's the first one. If we know what the sine of theta is, that can go here. It's just substituting what its value is in for that. plus, we have cosine theta squared equals 1. And cosine theta is one of these identities that we're solving for. So here, when I square negative 1/2, that's negative 1/2 times negative 1/2, that's 1/4, plus cosine theta squared equals 1. I'm trying to solve for this. So I'm going to isolate that by subtracting 1/4. And I'm going to have a statement that says cosine theta squared equals 3/4. 1 minus 1/4 is 3/4. And this is what I want to know. And that's being squared. So what do? Take the square root. And once I take the square root, I have cosine theta. Now, here's where things get a little chippy. Because when I take the square root of 3/4, that's the square root of 3 over the square root of 4. But listen up to this part. When we take the square root of something, we have to include positive and negative outputs. Okay? Right? Anytime we take this, what's the square root of 9? 3? Well, it's technically plus or minus 3, positive or negative, right? We're not sure. We clean this up just a little bit right now, and we have this. And it would be great if I could just put a box around that. However, we do have to consider the idea that if the sine is negative and the tangent is positive, we still need to know where that angle is to make sure we get the absolute correct answer. We've already said we think the angle's down here in quadrant 3. That still matters. It still matters that we know sine values are positive, cosine values are positive, tangent values are positive. Sine values are positive, cosine values are negative, tangent values are negative. Sine is negative, cosine is negative, tangent is positive here. And then sine is negative, cosine is positive, and tangent is negative here. That still matters. Okay? And this has already been covered, right? Use that, pause it if you want, add that in your notes again if you'd like. Okay? But it matters to know what quadrant we're in. We know we're in quadrant 3, so our cosine value that we solved for, we only want the negative value of that. Okay? So the real answer here is negative radical 3 over 2. This new smartboard is very sensitive. Okay? And then for secant, flip it over.